Hello everyone, I'm Paul and today we're solving problem 2353, design a food rating system. This is medium, so next I will show you my intuition, approach and efficient solution. We need to implement the food ratings class, so first we need to create some data structures and then we need to implement two methods, change rating and highest rated. Let's start with this one first. Here we need to return the name of a food item that has the highest rating. So we are given some cuisine and we need to return the name for some food item which corresponds to the highest rating. And this looks a lot like a map. And this is the first observation here. We can have a map where each key is a different cuisine and each value is a sorted list. And why are we using sorted list? Because we need to find the highest rating quickly. So if for some cuisine we have this sorted list, we can take the last element and here we have the highest rating. We know this corresponds to this food, so we just return B. Now the problem is the following. If there's a tie, we need to return the item with the lexicographically smaller name. So if there's a tie here, we can't return this, we have to return this instead. Let's see how sorted lists work. First, we are sorting items by the first element, and then we are sorting items by the second element. The thing is, we need to sort items by the first element in ascending order and by the second element in descending order. So the trick here is to store every rating as a negative value and then we can just return the food item corresponding to the first value. We know that the rating here will be the highest rating and we know that if there's a tie, this will be the food item with the lexicographically smallest name. Now let's go to this method, change rating. We are given some food and some new rating. So we need to change the rating of this food. Now the question is, how can we update this if we only have this data structure? We need to find some way to know which cuisine this food corresponds to, and we need to find a way to update these values here efficiently. So the trick is the following. We can build another map where we have foods as keys and ratings and cuisines as values. So for this example, we have this food. For example, food A has a rating of -1 and the corresponding cuisine is this cuisine. And when we call change rating with some food and some new rating, let's say here we have food A and the new rating is 2. First we go to this map and we look for the corresponding food, in this case A, and we need to extract one key from this. We take the old rating -1 and the name for the food A. And now we go to this map and more specifically we go to this cuisine, which is this cuisine, and we are looking if we have exactly this key here, and we have it right here. And remember, we are using sort lists here, and we have a method that's called discard, and it runs in log n time complexity, so we are using that to remove this tuple. So we remove this. Now we can update this old rating with the new rating. Now we have a 2 here. And now we can take the new rating, -2, and the name for the food, and add this up here in the corresponding cuisine, meaning in this cuisine. So now when we call highest rated with some cuisine, we can go to the corresponding cuisine and we take the first element. We know that this one has the highest rating and we return the food name corresponding to this first element. Just to make this clear, let's say now we call change rating with food B and the new rating is 2. First we go to this map to food B. We need to extract a key from here. So we create a tuple with the old rating -1 and the name for the food B. Now we are checking in this cuisine, meaning in this cuisine, if we have this key. We have it right here, so we can remove this. Now we can update this rating with the new rating. Now here we have -2. And now we can add up here a tuple with the new rating -2 and the name for the food B. So now we have a tag here, and given that B is lexicographically larger than A, we know that this tuple has to be in the second position. And now if we call highest rated with this cuisine, well, we go to this cuisine and we take the first element and return the food corresponding to this first element, which is A again. So this is it for the approach. Basically, we need 2 maps. And with this in mind, let's go with the code and hopefully you will get the idea. First, we are building the map for cuisines. So we'll call this cuisines info. And this is a default dictionary with a default value of short list. And self.food info. This is just an empty map. Remember that every food is unique. And now we can say n is the length of foods, and for I in range n, self.cuisinesinfo at the current cuisine since I dot add. And here we need to add a tuple with the current rating, ratings I, and the current food, foods I. And remember, this rating has to be negative. And now we need to populate food info, so self.food info at the current food, foods I. This is a tuple with minus ratings I and cuisines I. So now let's go with this method. We can just return self.cuisines info at the given cuisine, at this cuisine, at 0, 1. So we need to return the food name for the highest rating in the given cuisine. Okay. And now let's go here. We need to take the old rating and the current cuisine, and we can do this with self.food info at the given food, at this food. And now with this information we can update self.food info at the given food, and this will be a new tuple with the new rating and the corresponding cuisine. And now we can remove the corresponding key from the map for cuisines. So self.cuisinesinfo at the corresponding cuisine.discard, and we are removing the corresponding key. So remember, here we have the old rating and the food name. And after doing this, we can add the new tuple. So self.cuisinesinfo at c dot add a tuple with new rating, and the food name. So this is it for the code. Now let's submit this and see if it works. Here, this is cuisine. This is this cuisine, the given cuisine in the argument for this method. So let's submit this and try again. As you can see, this works and it's efficient. Time complexity for this part will be big O of n times log n. Remember that operations for sort list require log n time complexity, and in the worst case we can have only one cuisine and every food corresponds to the same cuisine. Time complexity for this part will be big O of log n, and here it's big O of 1. And space complexity will be big O of n, where n is the size of the foods array. So this is it for the code. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.